So I'm still back on example 1. I just broke it up into 2 different videos so that I could integrate by x's first, and now I'm going to integrate by y's. That way you guys can compare and contrast the 2 different methods that we have for integration. Remember, it doesn't really matter which one you use. Sometimes one of them is going to be easier than the other, but I'm allowing you to make that decision about this specific problem in general. So don't always assume one way or the other. Make sure you look at it and say, is this way going to be easy, or is the other way going to be easier? In this case, I'm revolving around the y-axis again. I have this region that's over here on the positive side, the first quadrant. And so what I'm going to go ahead and do, I'm integrating by y's this time. So I'm going to take that y equals x squared, and I'm going to convert it into in terms of y. So y equals x squared, I'm going to square root it and get the square root of y equals x. Remember, I normally put a plus or minus here, but since I'm only worried about the first quadrant, I'm only going to worry about the positive side. Now, other thing I want to make sure I mention, if I'm looking at the y values here, I'm integrating from 0 to 2, not from 0 to the square root of 2. That is a common mistake of people still use the x bound when they're integrating for y. So that's an important distinction here. Now, based off of that, I want to go ahead and look at trying to represent my radius and my height. Now, in this case, my radius is from this y-axis over to this curve, which just happens to be the square root of y. But at the same time, that's also my height. Okay, so that's an important distinction to make. Is in this case, instead of using x's as my radius and my function as my height, I have to use both. I have to use the square root of y both times. So the square root of y is both the radius and it's also the height. So let me go ahead and start working on this. So what I'm going to do in this case is I'm going to take the square root of y and I'm going to treat that as my f of y. Okay. And you're going to see how I get to this in the end. So if I take f of y, which is the square root of y, I'm going to rewrite it as y to the 1/2 to make my life a little easier. I'm going to go ahead and take its derivative, which gives me, make sure you multiply by 1/2 and drop that from 1/2 to negative 1/2, which again, remember, negatives make it move to the denominator. So that's going to be 1 over 2y to the 1/2. And I'll go ahead and rewrite that as 1 over 2 square roots of y. Now that I've got that taken care of, remember we need to go ahead and square it next. So f of y squared. Remember to square everything. So I'm going to have to square the 1. I'm going to have to square the 2. And I'm going to have to square root the square root of y, which is just y. So I get 1 over 4y. Now that I've got that taken care of, remember to add by 1. And I'll go ahead and do it in the same step and put the square root. So it's going to be the square root of 1 plus 1 over 4y. Now I am going to go ahead and make a common denominator and kind of work from it there. Hopefully as you guys see this, it's going to get easier if I do it this way. So let me go ahead and do all that work while I'm standing here. So if I make a common denominator, I'm going to get the square root of 4y plus 1 over 4y. What I'm going to go ahead and do is separate the square root real fast. So it's going to be the square root of 4y plus 1 over the square root of 4y. Now hopefully you guys are thinking that I can do the square root of 4, so I'm going to have the square root of 4y plus 1 over 2 times the square root of y. Now that's going to be important in just a minute when I go ahead and start plugging everything into my integration. So let me go ahead and start writing my surface area. So the surface area is the integral. Again, we're starting at 0, we're going y value to 2, okay? When I go from 0 to 2, here's what we're going to do next. I'm going to go ahead and write 2 pi times my radius. Again, my radius is from here to this edge, which is the square root of y. So I'm actually using the square root of y as the radius. And then I'm multiplying by this function that I found here, this square root of 1 plus that thing. And so in this case, I'm going to multiply by the square root of 4y plus 1 over 2 square roots of y. Now notice, if I'm paying attention very carefully here, I've got a 2 on top and I've got a 2 on bottom, so they're really going to cancel. I've also got a square root of y here and a square root of y here, so they're going to essentially cancel. And so what I'm going to end up actually getting here, once I've done that little bit of simplification, I'm going to go from 0 to 2 of pi, which I can actually even take out. I don't even have to write it on the inside the integral anymore. That's gone, so I'm left over with the square root of 4y plus 1 dy. Now, once I've got all that done, I can make a u substitution. So that's what I'll do. U equals 4y plus 1. So if I plug in those bounds, if, y is 0, plug in 0, we get u is 1. And I'm going to go ahead and plug in y is 2. I'm going to get u is 9. Think about it. 4 times 2 is 8 plus 1 makes 9. So that's my new bounds of integration from 1 to 9. And I'm also going to go ahead and figure out du so I make the switch correctly. I get 4 dy. So make sure 1/4 du is dy. So I am going to end up dividing by 4 in here, but that's going to not be as nasty as what might have been. So I'm going to do pi times 0, or pi times the integral from 0 to of u to the 1/2. Don't forget to multiply by that 1/4 du. Okay, so I'm going to take care of that 4, or that 1/4, excuse me. I'm going to get pi over 4. Ooh, I should have switched my bounds of integration. Should have switched my bounds of integration because I'm going from 1 to 9 now. Don't make the mistake that I did. All right. So I took care of the 1/4, so I need to go ahead and integrate that u to the 1/2. That's going to become u to the 3/2. Don't forget to multiply by 2/3 or divide by 3/2. Don't forget we're going to integrate, again, new bounds 1 to 9. So now that I've got that taken care of, I can go ahead and simplify a little bit. That's going to be turning into a 2, so I'm going to end up having pi over 6 of u to the 3/2, which is 9 to the 3/2 minus 1 to the 3/2. Remember, 1 to the 3/2 is just going to be 1. 9 to the 3/2 is going to be 27, so I'm having pi over 6 times 27 minus 1, which is going to give me pi over 6 times 26. And remember before when I simplified, 6 and 26, I end up with 13 pi over 3. Wow, look at that magic. Worked out to be the exact same answer no matter which I integrated by, x's or y's. So let me repeat again. I'm allowing you to make the decision. Is it easier in this problem to integrate by x's or is it integrate by y's? Personally, I don't see a big difference. I think the mistake that people are going to make most often is forgetting that this radius in this case is a square root of y again instead of just a plain old y. So let me repeat. I think there's not a big difference between the two methods in this problem. In some problems, it really is. So make sure you pay very close attention to what you are doing and make sure you pay attention to your radius and your height, okay? I'm going to come back and do another example in just a hot second.